CT excitation test part 2. To perform this test, the first parameter to be entered is the CT secondary resistance. This resistance is used to estimate the knee point and is selected from the maximum RCT field by default. But if the resistance test has already been done, this resistance is selected from R measured. Note that since some users skip the resistance test and try to directly perform this test, this field can be edited manually. The knee point is estimated using the formula in EFS field. The importance of this number is the test evaluation in a way that for measuring CTs, if the knee point is smaller than this number, the test passes, otherwise it fails. For protection CTs, for the test to pass, the knee point must be bigger than its number. After the resistance value is determined, the test setting is entered in state setting. By checking demagnetize option, the software demagnetizes the CT with AC voltage and current before doing the test to remove the residual flux caused by the resistance test. In this section, the demagnetizing time and voltage should be entered in percentage of V end. In the next step, if calc from test object is checked, the software calculates the frequency and final voltage of the test by using the information entered in test object. If you wish to enter this manually, you should uncheck this option. In excitation time test field, the test time is entered. Note that it is possible to show the saturation curve with less fluctuation by increasing the test time. In Choose Current Management Mode section, it is possible to specify the maximum current from among low current with maximum 500 mA and high current with maximum 800 mA. Note that by selecting any of these options, the wiring changes. Performing the test and analyzing the results. In this test, the test information is entered in this page in accordance with the information entered in test object and the performed resistance test. Also, the wiring is done according to the CT specifications, which are different for different models of CTs. Note that in this wiring, output voltages is connected to the capacitor positive output, and it is necessary that the two negative polarities of the capacitors are connected to each other. By clicking on Init Test, the needed states are created in Table View, and the necessary changes are automatically applied in Signal View. Note that the voltage is displayed in Signal View in form of RMS, and it is possible to change the view to sine by selecting Instantaneous option. After performing the test in Signal View, you can see that the first CT is demagnetized and then the excitation test begins. In List tab, the saturation curve can be viewed in terms of voltage and current. In this curve, the linear area between the two plus signs is depicted in pink. After finishing the test, the knee point and the saturation point are depicted with green, and the results and the evaluation are recorded in excitation results section. Since in performing this test, the saturation curve points are of significance too, by selecting Add to Report option, the points used for the test are added to the report. Another important point in an excitation test is the current which passes the primary of CT and causes the saturation. Since this current is related to the CT connected resistance, in calculation of I primary section, the connected resistance should be entered in RL field, and then view the current that causes the CT saturation in I prime field. Here you can see that the formula used to calculate this current. If you wish to set the wiring in a way other than the suggested way, after clicking on Init Test, check Don't Change Hardware Setting. Then make your desired changes and initiate the test. Note that if before finding the saturation and knee points an overcurrent error is displayed, the wiring needs to be changed from low current to high current, and then initiate the test after pressing Init Test. If again before finding the knee point, the device is displaying an overcurrent error, this means that the knee point current is higher than the range of the device and it is not possible to find the knee point using this device.